All right. Do we have another one? We do have another one. Hooray! All right. See what? See how far you can get? All right, what's the domain? Good. X is not equal 3. Intercepts, let's start with the x-intercepts. Set the numerator equal to 0. What do you get for x? Yep, just -1. Because this factors as x plus 1 quantity squared. Be careful when you factor this, you do not write x plus 1, x minus 1. Is -1 a possible x-intercept? Yes, because it's in the domain. It's in the domain. So its corresponding x coordinate, -1, comma 0. Boop. How about the y-intercept? Make all the x's equal to 0. Yes. KO. Yep, upstairs you get 1, downstairs you get -3. So -1/3. So you'd say 0, comma, -1/3. Put the numbers not in the domain into the numerator. We only have one number here, 3. If you put in 3, do you get 0? Nope. So what happens at x equals 3? The vertical asymptote. Again, write it as an equation. What's the degree of the numerator? Denominator? So the degree of the numerator is 1 more than the degree of the denominator. Oblique asymptote. To find the oblique asymptote, use division. Since we're dividing by something linear, we could use what type of division? Synthetic division. You could always use long, but synthetic I think is faster. You don't care about the remainder, just the quotient. So 1, 3, 5, stop. Because this says y equals what? X plus 5. If you want to find the remainder, that's cool. Does not mean anything. So as far as the graph, part A doesn't directly affect the graph. Part B, we have an x-intercept at -1. Y-intercept at -1/3. Yep. And we have an oblique asymptote at x plus 5. So that means it's going to go through, well, how can we do this? Y-intercept is, oh, Mike, yes. You did not provide enough graph paper. No, you didn't, did you? That's okay. Y-intercept is 5. See, this is what's going to, oh, this is terrible. Oh, I'm not even, oh, geez, please. Oh, yay! Wait, no, you're not supposed to, you're supposed to stretch out. That's good enough. All right, unfortunately, this one is on the ugly side. So we really would need a calculator for this one. So if I did give you one on a test, it would probably be a transformation kind like the previous guy. So if you want to throw this in your calculator, do so carefully. Oh, I did not mean to hit that button. I'll just do this. When you throw this into your calculator, what should you put around your numerator and denominator unless you like to make mistakes? Parentheses. So if you would, go into your y equals. Throw this into your numerator and your denominator using parentheses. In your window, please make it a standard size. We got a problem. That means our window isn't big enough. Yep. So as it turns out, from doing a standard size window, we're not seeing enough information here. So what you might have to do is bump up the X max and bump up the Y max. Let's see if this is better. Oh, there he is. He's way up there. He's hiding. So if you were to graph this, it'd probably look something like follow along this asymptote, go through these points, follow along that asymptote, and then way up here you have another piece. But unless you, A, want to plot more points, like plug in 1, plug in 2, plug in 4, plug in 5, you can't plug in 3, or B, want to wait until calculus, there really is not a way of knowing what this graph will look like. So we're at a standstill here without our calculator. Yep. Yep. From here to here. So what happens is your calculator is in what's called connected mode. So if you go to second format, format is above zoom. Oh wait, maybe it's not in here. Maybe it's in mode. Yeah, go to mode on your calculator and see how it says connected or dot. What connected tries to do is it tries to connect adjacent points. So it's drawing this point here, and then all of a sudden it's trying to hit this point here, and it accidentally draws in the vertical asymptote that's not supposed to be there. So that's going to come about on your window size. Like if I had changed my window, I might have seen that as well. Or if you want to switch to dot mode, you can get an idea of what's going to happen. The only bad thing for dot mode is when it's a quick change, they're really spread far apart. So you might not get a good shape of it. But if it's not as small of a change, you're going to get a lot of points right next to each other. So it's not a bad idea to flip back and forth between the two to get an idea of what it looks like. But yeah, you didn't do anything wrong. It's the calculator. Bad TI, bad.